I have been programming since I was 16. Programming for me has always been a tool. I don't have a degree in programming. My PhD is in pharmacology, and I program for the Human Genome Project. So I was one of the first generation of computational biologists. Programming enabled me to solve problems I couldn't do just with biology, and enabled me also to extend my analytical abilities and extend the power of what I could do. Then 24 years ago, I became what is known as a US patent agent. That is like a patent attorney, except that I do not do regular law. In the US, some patent agents, patent attorneys also do law. I do not. I just do patents, and our focus is to help startups. We mainly work with startups in the pre-launch to launch stage. That's usually where they come to us, and then we work with them through the scale stage. And quite a few of our clients have exited by being bought. Okay, so I'm gonna ask now, what is your goal? When we spoke with startups, we work with them typically, as I say, at the pre-launch and launch stage, and then we work with them through all of their goals. Patents are one way to help them achieve their goals because, for example, when you file for a patent, it adds $1 million to your valuation. But clients were coming to us and asking for more than patent help. We had wanted to increase access to patents by lowering prices, which we did, and also by looking at including automation. But our clients were saying that they wanted help with all phases of their innovation. And in particular, they wanted to be able to have access to resources. One of the issues is simply finding the right resources. It's hard to do. Typically, people find folks to work with through word of mouth and perhaps a recommendation. Maybe they'll Google someone online. So for all of our goals, our clients are coming to us and saying, do you know a good developer? What about marketing? What should I do with my business model? How can I find help? And so we developed KISSPlatform to help support all of their goals all throughout their life, from pre-launch all the way through to exit. So what does KISSPlatform do? That's actually a screen share of the screen itself with a nice plant next to it. KISSPlatform matches innovators to resources. So for example, as I said, you need developers, sales, or marketing. It will help you do that. And it's particularly pertinent today because our clients were having a harder and harder time with the coronavirus situation, being able to reach each other, being able to network. We had planned to launch before, but we actually launched on March 31st, right into the coronavirus situation. It does also help with patents. Future versions will actually include automated patent generation and automated patent searches. But we started with helping innovators find the right resources. And how were we able to do that? Well, we knew we wanted to help innovators. To understand the domain, to be able to do that, we need to understand the domain of their idea. Now, what does that mean? When it comes both to patents and also to resource matching, for years we had been categorizing clients. Are they a blockchain company? Maybe they're doing healthcare combined with AI or ML. We needed to understand what they were doing so that we could help them for our own manual process, and we brought that onto the platform. We then determined a more fine-grained view of the domain. How many different features are they incorporating? We did that through looking at entities, looking at the words that our clients used and the context of those words to develop that fine-grained view of the domain. And then we started to ask questions based on the fine-grained view, which enabled us to be able to match to resources. So we were actually doing this manually. At first, we developed a really good manual process, and then we started to move it online. Now here, we had a little bit of an issue of our own. I am the domain expert. I am the person who understands the patents, who understands what our clients need in terms of the resource matching. I'm an okay programmer. I wouldn't say great. Like I said, I'm more of a data scientist programmer than a programmer who's going to make everything work really well in terms of code. We had to figure out a way that I could work with the other members of the team and we could understand each other and share ideas. So to do that, we decided to use Jupyter Notebooks, which I'll be showing you in a bit. And we started with different forms of NLP, natural language processing, to help understand the domain of our client's idea. Now, the natural language processing frameworks we're using are all Python-based, or primarily Python-based. We're using Python as much as possible for every stage of what we're doing, and we even have production code in Python. I do realize that Python may not be the best for production code. Folks are saying, well, maybe you should move it into C# or C++ or something else. We haven't seen such a big performance drag yet that has really caused us a problem. So even though we're using natural language processing to understand the domain of our user's idea and then find a more fine-grained view of that domain, we've been able to keep it in Python, even for production level code. Currently, we are also using a mixture of static question trees using, I will admit it, Typeform. This is to enable us to extend the natural language processing. Our goal is to gradually replace the typeforms, which are static question trees, with more natural language processing. Now, in this respect, what we're doing is actually quite similar to the way NLP is done for e-commerce. Let's say you are chatting with an e-commerce site and you ask a question, where's my package? That site will use NLP to understand your intent. It doesn't actually understand your sentence. We're not talking human level understanding at all. It's trying to guess what you want, and then it's trying to help you find it. So in the case of e-commerce, their strategy was to use NLP to guess that the problem was about shipping, that you'd ordered something, that maybe it hadn't come in. The where indicates that perhaps you don't have it. And it tries to guess what you want, and then they ask questions to narrow down what it is that you need. So we basically borrowed this strategy from e-commerce. Using NLP to get as far down the road as we can, again using Python, then switching to static question trees, which will eventually be placed with more NLP. And finally, when we feel that we have enough information about what the client wants and what the client needs, then we're switching to matching software. At the moment, this is offline because we're still testing it. We're looking right now at different models we might use to make it more efficient and also more accurate. But again, all the testing we're doing to understand who our partners are and what our partners can offer in terms of resources, that's also being done with NLP. And also combined with, if necessary, some static questions. So it's the same strategy all the way out. And we wanted to launch something as quickly as possible, which is why we followed this strategy. This is what we planned at the beginning of Q1. This is actually a rather more artistic version of the drawing I put together. By the way, you may notice my architecture drawings kind of look like patent drawings. There's a reason for that. It's because I've spent so much time doing software patents that all my drawings look like patent drawings. But the idea is, you can see here on the left, we have a discovery service. We decided, by the way, to do everything as microservices at the back end. So we have our discovery service, which then goes to intermediate abstraction layer. We have a text input and output service. Our pre-processing then feeds the textual information to what we call our domain decider service. This is the service which is analyzing the user's idea to determine the domain. It actually involves multiple different NLP models and algorithms, some of which use simple word embedding, others of which are more complex. And we put those together in one service so that we could use ensemble learning. Now, ensemble learning is basically when, I don't know if everyone here is familiar, so I'll just take a moment. By the way, do ask questions. I'm not certain how much information everyone has, and of course I want to get to the code. So if you're not familiar with something, please do let me know. The idea behind this architecture is that we could feed all of the text into the domain decider service, which would then use the multiple models and ensemble learning to decide what information do we give back to the discovery service. Ensemble learning methods basically are machine learning methods. They can be simple, like voting, which is what you're using. Different algorithms all vote on what they think the right answer is. And then the ensemble learning looks at all the different algorithms and says, oh, yeah, this is the right answer based on my experience, or just based on a pure vote, based on weighting, based on whatever criteria you put in. By using this architecture, it also meant that we were able to quickly swap in and out our AI microservices without disturbing the rest of the architecture. The discovery question service was a fallback that we haven't really had to use much, which basically we simply ask some static questions if our domain decider gets stuck. Again, this is simply taking a page from e-commerce. When e-commerce companies get stuck, you may have noticed on the chat, and other companies do this as well, they just start asking you questions. They ask you questions based on what are the most popular things that people ask about. If they can't figure out what's going on, that's what the discovery question service did. And then we fed the answer through back to the user. The user then gets a chance to decide which of the domains are best. Right now we're feeding up 3 domains, the top 3 ones, and the user can pick 1, 2, or 3. That goes back in. It also gives us an extra layer of accuracy. Right now, our domain decider is working quite well, but on the edge cases, it's great to kind of have that backup from the user. Then we go to our discovery tour service, which, as I said, right now is done with static question trees. I'll admit it. But in the future, we also hope to go through with NLP. And the idea is by, first of all, having the user talk about their idea, we wouldn't have to put them on an infinite question tree. I actually did try doing this just with questions, static question tree. It was a nightmare. There were too many of them, and it was messy, and sometimes people had combinations, and it was horrible. This way, the user types in their idea, 50 to 500 words, and we come back with 3 answers. The user picks the top ones. It's much, much faster. We also then have more information about their idea, not only about the domain, which also helps us when we're doing the resource matching. So all in all, it's a win-win for us. And of course, we hope for our clients. Okay, so what we did for the models. So we are taking text. Here you can see a little bit there on the left of the screen that we had, where we are taking in some text information. We say, first, please describe your idea. This is some example text that we had. Obviously, it helps if there are words that are direct match for a domain that we're looking for, but it's not necessary. And we tested different models. We tested them at first with Jupyter Notebooks, word embedding models. So I, first of all, did Word2Vec, the GenSim version. Word2Vec has a few different flavors. The flavor that comes out of GenSim, I have found, is the easiest to use. It's quite stable. There are a few undocumented things about it. So if you do decide you want to use it and you run into some problems, let me know, because there's some things I couldn't find any information about in the documentation, but then I realized what was going on by poking at it. Sentence2Vec, also word embedding based on sentences. Wiki2Vec, this is actually a very interesting word embedding model. It uses the links in Wikipedia to decide, first of all, which concepts are important, and then which concepts are linked together. Wikipedia does not necessarily reuse links for some things, so they had to kind of enrich it artificially with some links. But it gives very interesting results. If you are interested in a model which was trained on Wikipedia because you want to use words which are very common words, then I would highly recommend it. It works quite well for those. It didn't work as well for analyzing our user sentences, you know, even like tokenize or removing stop words and all that, just because our users' ideas were involving a lot more technical information. Wiki2Vec does not work well then. Also tried Glove. I don't like Glove. It didn't really work that well for us. So we also looked at BERT and other transformer-based models. That was more the data scientist and AI engineer, who I'll introduce in a moment. And we did everything based with Jupyter Notebook-based tests. Jupyter Notebook is really great because you can obviously share it with people. It's easier for commenting. You're going to see my code on Jupyter Notebook. And it's testing code, it's experimental code. Jupyter Notebook enabled us to do that with Python really easily. So I can do super basic NLP programming, I would say. I can do good, you know, decent Python programming, but more as a domain expert. Our team has a data scientist and AI engineer, so we shared code review together through Jupyter Notebook. Python is super flexible and has a lot of frameworks and also allowed us to run a lot of experiments. So I super love Python for these things. And like I said, we're even using it on production level code. With a few tweaks, it'll work well enough for us. We haven't seen a huge performance penalty, but of course we have been warned by others this is not likely to last. And of course we can also upload the notebooks to Jupyter Cloud, which I really like. This is our team. This last slide before we get over to the code. That's me. Ty is an AI engineer. He is based in Ho Chi Minh City. And Mateos is our data scientist, and he is based in Warsaw, Poland. So we are a fully remote team. We work all the time on Zoom. I think I spend more of my life on Zoom than any other piece of software these days, maybe with the exception of Jupyter Notebook. And this allowed us to collaborate together. So it's a Jupyter Notebook plus Zoom, great combination. And now I'm going to show some Python. Does anyone have any questions before I leave the presentation? Because I have to switch over to my Jupyter Notebooks.
So there was one question that maybe you can help, Dvorah. So you mentioned Word2Vec and Wiki2Vec. Can you kind of articulate a little bit more between the differences between the two and some of your experiences?
Sure. So let me just go back up here. So Word2Vec is they actually has two versions. It is a word embedding model, meaning it basically looks for which words are closer in the neighborhood of other words, and it's all represented by vectors. It attempts to uncover relationships by words by seeing which words are more used around each other and therefore seem to be more connected. It is not looking for understanding. So it works really well if you have a lot of single words, and if you can characterize something, like classify something based on words as opposed to, say, context. BERT is obvious, and transformer-based models are obviously better for context. Wiki2Vec took that a step farther by looking at words and their connections based more upon how they were hyperlinked together. So for example, blockchain would be hyperlinked to Bitcoin. In the Wiki2Vec model, right, because in Wikipedia, blockchain and Bitcoin, if you go to the blockchain page, you'll see it linked to Bitcoin and vice versa. This means to Wiki2Vec that blockchain and Bitcoin are really connected. I believe they also use some regular Word2Vec embedding as well, but it's mainly based upon the links. And this is simply to decide which words are related. So Wiki2Vec is saying the humans already made all these nice links. The links show concepts that are connected because the human said that blockchain is connected to Bitcoin, but blockchain isn't connected to banana. I'm fairly certain I have not seen blockchain being connected to banana on Word2Vec on Wikipedia. So as a result, Wiki2Vec understands that blockchain and Bitcoin are related. They're important connection. They have a much shorter distance between them, or they have a greater degree of relationship, depending on how you want to look at it. Whereas blockchain and banana would not have that relationship at all because they're not linked. So if you were looking, for example, for their concepts similar to blockchain, you wouldn't find banana, but you would find Bitcoin with Wiki2Vec. With Word2Vec, it depends on the words people are using. We actually trained our models, word embedding, BERT, all the different models that we use. We train them on TechCrunch, which is an online news site. It's more Silicon Valley, California style writing. And also on VentureBeat. That is more East Coast, New York style writing, but also technically oriented. And like I said, Wiki2Vec didn't work for us because we have a lot of clients using a lot of technical words. And it just wasn't working for us, attempting to use Wiki2Vec. There were things that were related, but let me give you an example. I wanted to look at corpus, one of the words. If you're talking about AI, you might talk about a document corpus. Wiki2Vec said that corpus was related to Christi because Corpus Christi is an important city in Texas. It has a lot of industry. I believe it has oil refineries, and it also has a really well-known football team whose name American football team, sorry, not the real football, whose name I now don't remember. So you can see why Wiki2Vec wouldn't work, whereas Word2Vec, when we put in corpus, document was what came up. Is there another question before I go on to the?
Yep, so there are two questions. So one from Costa. So his question is, looking at the historical performance and the cases where the model didn't do a perfect job, what was the main reason behind its incorrect answer?
So in terms of the historical performance, where we are having problems were with some edge cases, where we had like descriptions of companies. Our training data, our testing data was based on using Crunchbase. And we had companies, for example, that did they were service companies and they did all kinds of different things. They claimed that they did blockchain, they claimed they did AI, they claimed they did pretty much everything under the sun. And so then there it didn't work well because it was just a bunch of random concepts that weren't connected. In other cases where the words did not seem to focus very much on the idea itself, or there wasn't a coherent, focused description of the idea. So for both BERT and for the BERT can help in cases, we found that BERT works well in cases where people are using words that perhaps we would not have flagged as being related to a particular domain. Word2Vec works very well, for example, with blockchain because it's a fairly limited set of words. So that's one of Word2Vec's strengths. In other domains where it's kind of loose, like let's say you're talking about software for healthcare, it tends to be loose. People use a lot of different words. The words aren't always so consistently used. They're different technical words may be used to describe the same thing, and then Word2Vec struggles because it doesn't understand what it's looking at, and BERT does better. But to be honest, where people are not using a lot of technical words or where they're not describing a single technical concept, it doesn't work as well, to be honest. It works better if you talk about one inventive concept, then it can understand it.
Very good, very good. And then the last question before you jump into the Jupyter Notebook, this comes from Mary. She's asking, are you using domain-specific ontologies?
So we actually are not using ontologies. I am not a huge fan of ontologies because I've seen folks try to do patent modeling. So I started off by doing some fairly basic NLP analysis of patents. That's how I started this project. It was about 2 years ago. And I looked at some ontology-based mapping, also some topic-based modeling. Does not work very well for these things. My personal feeling is that you would think it would work because we were looking at a domain, but the concept of the domains we're looking at are squishy and they're fuzzy and they overlap. And a lot of times, many different words may be used to describe very similar concepts. And those things didn't work for us. Okay, should I jump into the code then?
Yes, yes, thanks a lot.
Okay. Okay, let me do a new share. Just want to make certain you can see okay, can you see the code?
Yes.
Okay, so this is my Word2Vec, I call it the experiment. This is the code which I would use when I want to train it on a new corpus. I can also use it to run different things to get out basic information. This is like a fairly early notebook that we were using. You can see I'm importing GenSim, using RE, of course, for regular expressions, NLTK corpus, imported stop words, CSV, all the basic things. From the GenSim test utils, I also imported get temp file. Now, when I was importing GenSim itself, I, of course, should be able to get all of the different things, but I found that having both imports actually worked a bit better for me. That could be something I was doing wrong with it. I don't know, but that's why I did it like that. And of course, NumPy and some of the other ones. So what we're looking at here is we're reading in a lot. I used a yield because I want to do a generator. Basically, when you're doing the training, you just have to read in all of your input files once. And I'm doing this on my computer. I'm not doing this in the cloud. And I didn't want to overwhelm the memory for it. So like I said, I used the simple generator. I used the logging thing so that it would report what it was doing, which you'll see at the end. Helpful in case I was wondering why the heck it was getting stuck, which I did have some questions about. Word2Vec, basically we grabbed the model. These are the basic parameters that I started with. Size as 148 worked quite well for me. In general, with Word2Vec, they do recommend that you're doing it in groups of 4, which is what I was doing. Something will flash up and it'll give you a recommendation if you're doing something different. You can do obviously whatever you like. Window size, the min count, the workers, these are recommended to me, and also the epochs. Obviously, you could train more, but I found that this particular setup worked really well, didn't take too long to train, and enabled me to quickly switch between all the different document corpuses I was doing. So here I have some basic things: opening, reading, and writing content, including from CSV, preparing the user input. Here, I had the words coming in, which I would split, made them all lowercase, remove the stop words. So stop words are like a and the. This stop words, of course, is coming from NLTK. So just so you know, that makes it work better. And then I would turn it into a set, make a dictionary, run the whole thing, and would return that. When I wanted to test the text similarity, I would first of all check that a word was in there. You could also use try. I happen to use this particular way of doing it. Model.wv.vocab is the way you call Word2Vec. So you put a word and you ask, is the word in the vocabulary first? And then if it is there, then I would run through and check it for similarity. So model.wv.similarity allows me to check the similarity between two words. One is, of course, my test word, and the other one is a word. And that way I can run two tests. So with Word2Vec, you're basically running one word against another word, and you can see how similar they are. You can also grab the top 10 or top 20 or top whatever most similar words that you want with Word2Vec. I use both. Word2Vec does have a bigram model if you want to use two words at a time. You can see one big disadvantage is that artificial intelligence becomes split up to artificial intelligence. It causes some problems. It's not the best, but we did not find it to be completely problematic. Then I would basically run this to check for the matches. I would append a probability only if the probability was above a threshold. And now we're coming, I'll just skip down to the end for a second. So here, basically, I'm starting. If I said yes, that I wanted to run Word2Vec, I would enter a file name. All articles.txt was kind of my default file name, and that way I would just remind myself that's what I need to do because I end up with like a lot of files running around. I just find this easier. Model, I would run Word2Vec on the data file. I would get the temp file name, F name, save it. That way I would be able to find my model again. As you may have noticed up here, there is one note. This is something I did not find in the documentation, so I put it in as a comment. In order to get Word2Vec to work, if you're using a pre-trained model, so here I'm training, but let's say I wanted to use a pre-trained model, like here. My model file, this is like a trained Word2Vec 2 model. That was simply the name. I also have a version where I can input it, but usually I'm lazy, I just use the same one. You need to have one model file and two NPY files. So the naming is always the same. If the model file is called trained Word2Vec model, then this is what the two MPY files are called. And they all have to be in the same folder as the model file. Now, I typically will use Anaconda Navigator to navigate to a particular folder. I'll just dump everything in there and I'll run it. Yeah, I mean, it's a bit lazy, but I just may want to solve a problem quickly, and I just find this easier. So that was not in the documentation, that little note. I had some fun figuring that one out. Noodled around a bit, located some files, gave it a try, figured it out. Once I decide if I'm running or not, then I decide the kind of test. It could be manual or automatic. If it's automatic, then I would enter a threshold, and I would test against a particular domain with the threshold. So I would upload a CSV with a certain number of words. If I wanted to test against those words, for example, call that with model on my threshold, and then I get an answer spitting out. And otherwise, I could have a word list. I do tend to put in defaults, which I'll often comment out, again, just to make it go faster. And then I would create a domain CSV, which is basically a nice list of words that Word2Vec believes is related. Now, this version I use to actually mainly to create the lists of domain words so that we could better explore the domain words for our Word2Vec version. We were using these words to say, this is our bucket of words. We're using this bucket of words to test against your text. Are the words in your text that are not stop words, are they closer or farther from this domain? Does it overcome a certain threshold? Yes or no? And then we would just simply dump that into the ensemble learning. And this just simply shows, I did this before because I wanted to show you where it looks. All right, so we're reading in the articles. You can see, sorry, hang on a second. Sorry about that. So you can see we had over 10,000 articles. Sorry, over 100,000 articles. We're treating each article like a giant sentence for our training of Word2Vec. Word2Vec itself, as far as I know, and I've had some discussions with folks, but most folks have told me that they agree with this, because of the way Word2Vec is set up, you cannot fine-tune train, you can't transfer, learn, train, you have to train it from scratch. So I basically trained it on all of the articles to figure out which words relate to which other words, over 100,000 articles, but it works quite well, actually, even with much less information. I did try splitting the sentences between the articles, did not give me a good result, so I kept with the articles. And the idea is that you could have different sections of a document, for example, could be an article. So when I analyze patents, and I'm not treating the whole patent as an article, but different pieces of the patent have come under different legal pressures, and the words used are really different. So the background versus the abstract versus the claims versus the description of the drawings, those I've also used as each one of those being an article. So each patent will have multiple articles, and that way I can see which words are used for each one. Of course, you can also slice and dice however you want to do it. You do not need nearly this much data. You can do it with much less data. And then it kind of chugged along, and it goes chug, chug, chug. I have a decent laptop. I wouldn't say like a super great one. It takes a little while to chug through. So there we go. We're training. And there we go. Go through all our epochs. Yep. And anyway, this continues like this until you get through down to the end, and then you can run it and look for some information. And I just wanted to show the result here. So Solar, when trained on the TechCrunch, over 100,000 articles, each article is a sentence. The word solar, I asked for the top 10 most similar, so that's top n equals 10. If I want the top 20, be top n equals 20. I said in my trained model, I'm looking at positives, that is, I want to know which ones are the most similar. Give me the top 10 ones, and this is the result. Jensen is quite well documented. All of these commands are super well documented. Not the what you have to do with the trained model, not so well documented, but it's fixable. And you can see these are very expected results. Kilowatt, energy, electricity, thermoelectric, poles. Sky, I think, is a company. That was the only one that was a little interesting. But again, this is TechCrunch. That's what they're talking about. You can see in this case, not getting a huge amount of similarity to the word solar might be because TechCrunch doesn't talk about that as much as it does software. For software type words, I do tend to see better results from TechCrunch, but there are other, of course, other document corpi that could help you do that. Any questions about this?
So there's one question, maybe just a clarifying question from my side, Dvorah. So when you kind of, how long does it take to train all of this? Is this kind of like a day's work, or is it
no?
Is it like a week, or
no? It's not even a
just
day.
Trying it out a little bit, and in the reality, it takes longer. Can you speak a bit about timing and how long it takes?
To be honest, I didn't find it takes that long, depending on how big your document corpus is with Word2Vec, and you have, assuming you have like a pretty decent computer, you're looking at anywhere between 30 minutes to maybe a few hours if you have a lot. I mean, if it's a small enough document corpus, it may only take you 10 minutes. That was the other reason I liked Word2Vec, is it allowed me to try a lot of different experiments, whereas transformer models, apart from being a lot more complex, obviously wouldn't allow me to do as many things and try out as many ideas. So I like Word2Vec, real fast. Wiki2Vec, of course, you use their pre-trained models and they work right away. Sentence2Vec, I found took longer to do. It doesn't necessarily going to train that fast. You're probably looking at a few good hours, but it could also be longer. And, you know, BERT, if you're doing BERT with like a lot of stuff, even though it's like a fine-tune training, you're not retraining from scratch. If you did that, it would take way too long. But even with like just fine-tune training and with GPUs in the cloud and everything like that, you're looking at a few good hours to like even a day or more. So it depends on what you want. And if you do want to do like a quick and dirty test, Jupyter Notebook Python, Word2Vec, I like it. But if you want to do something more complex, then obviously, you know, it's going to take longer.
So then just from my understanding, so thank you for that. So just from my understanding, so this KISS platform or that you've kind of developed, this was your first attempt as almost like a researcher to kind of get your algorithms up and running. And then I'm assuming you take this and you hand it over to the other person on your team. And then that kind of goes in production. So just out of, what does it look like for a customer of yours? So a customer kind of comes to you and says, hey, I've got this patent, here's the text kind of thing, you run it, and then what do they end up seeing? Can you maybe speak a little bit to that?
Well, so
For
what
those
they
of us who are not super ingrained in the patent process.
Yeah, so I'm afraid that what they end up seeing right now is, let's see, what they end up seeing right now is they end up at the end, they, here I can actually, let's see if I can get, I don't know if that's gonna work. So what they end up getting is, right now what they're getting is an email report, which depending on what their idea was, how we analyzed it, and the questions that they answered. So for example, are they pre-sales or sales? Are they having difficulty with sales? Things like that. Then what we would do is send them a report. Which simply looks like a number of blocks of text where you answered, you gave us this information, here's your domain. We give them answers to all their questions, and the way they answered them. And then we just have blocks of text. So the user actually is just getting like a list of resources and our recommendations. So for example, if you're post-sales, you've already started selling, so you've already published your idea, but you're less than 12 months in for your sales, you can still file in the US, but you have to keep an eye on the deadline. So in that case, we'd recommend considering filing for a patent quickly, if in fact a patent seems appropriate for your idea. Not all ideas that come to us are best done with patents, right? If it's a manual process, it wouldn't be for a patent. In that case, we would recommend other resources such as, for, like I said, a developer, a sales coach, etc. So it just looks like the same kind of report we were sending to our clients manually, only now we're able to do it through natural language processing. And this is the first step for greater automation on the patent side, and also greater automation for the partner matching, so that ultimately our goal is for them to be able to just have the answers flash up. And then what I showed you there were my first attempts at doing the programming. Like I said, not like a super great programmer, more of a data scientist type programmer person. But I was able to get through some things really quickly, and then I was able to explain to my team what I was seeing, what I understood was happening, why it was important, what were the problems I was still running into, and that helped put them on the right path for understanding how we could better characterize the user's domain. Like, how could we answer the user's question better, which is, I need help, I don't know what help I need, please help me. That's ultimately the user's question. We're able to do this working as a team. Obviously, they're much stronger on the AI, natural language processing side, but the initial experiments allowed me to talk with them. It gave us a common language. It gave us a common example that we wouldn't have had otherwise. Does that answer your question?
Awesome, awesome, very inspiring. So I've been part of the patent process, and it's a painful thing, so I appreciate any automation in this process. So thank you very much.
Awesome, well, thank you so much.
There's a question from René, is how do you evaluate / rank the trained models?
So what we were doing there is we were looking at, we had a number of different measures, and that is actually more what the team was looking at rather than me. We were looking at, two things. One is we're looking at F1s, obviously, to see what, how we could best rank them. So one of the issues is you have this issue, you want to be accurate, but you also have to look at the how many different samples are actually, how many different samples do you actually have in your training data, and what are they showing, and how do they are they categorized? Because we did not have a balanced training data set. And sometimes typically for natural language processing or any kind of AI, a balanced training set is recommended, but we didn't have that because some of our domains didn't have so many samples. So we were looking at F1 to try to solve that. And then beyond that, for the voting, what we found is that some of the models, we kind of tipped our thumb on the scale a bit. Some of the models worked much better for blockchain, like Word2Vec, fantastic for blockchain. Not so fantastic for healthcare patents that use software, like that use software as a basis. Didn't work very well for that. So we kind of chopped and sliced all the different domains and more fine tuning of the domains we're looking at. And we put our thumb on the scale sometimes to say it's not the absolute number, but in these situations, we've seen that this works better. But now, of course, we're going beyond that. We want to actually fully train a model that can do this more. But this is just kind of a quick way to be able to get something up there so we could test it, get people using the idea. So if you go to KISSPlatform.com, it's free. You can use it. Please give us feedback. We always really appreciate it. And to look for issues, because the next step that we will be doing will be automating patent drawings for software patents first, and after that, patent writing. Again, for software patents first, followed by others. So we wanted to test this part and also test the resource matching so that we were no longer doing this manually, and so that we could also reach out to more folks and work together. So we see it as like really a way, we want to build a community, and that's really important for us. Another question?
So I think that is it for the time being, Dvorah. So I wanted to thank you very much for your talk. I think it's very inspiring, and it's really cool to know that this is coming out of Eindhoven is the starting point, but it's a global initiative. So that's very cool to see you doing that. I'm sure you'll stick around a little bit longer. So if people have questions, and for all those who are curious, feel free to go and check out the website, look at it, and I'm sure you're open to collaborating in the future if need be, right? For all of those of you think you can do better, right? And contribute.
Well, first off, if anyone thinks they can do a better job, please come talk to me. We need all the help we can get, seriously. But also, if I can answer any of your questions about anything, patents, NLP, the data science thing, I don't know, anything that can be helpful, I really would really like to be able to do that. I love meeting people. It's harder doing these virtual meetings because I don't get to meet the folks. So I obviously want to be able to talk to folks. And thank you so much, Gareth, for giving me this opportunity. I really enjoyed it. And I will stick around, but I am going to mute myself now.
Very good then. Thanks ever so much, Dvorah. Wonderful talk. So with that, I'm going to hand it over to Billy Zhao. So he's calling in from London. He works for AIforGood, and we were looking for a talk around the coronavirus, and he's got an inspiring story to share with us. It's so inspiring that he's even changed his background, which we very much like in the video, so that's cool. And Billy, I'm going to let you take it away. So thank you very much. I appreciate you joining us today all the way from London.
Right, no problem. Nice to meet everyone on here. I will just share my screen really quickly. I'm a little bit lost in. Oh yeah, there we go. Share screen. Cool. So I'm talking to you guys from London, and about this project that we started at the start of April. So it's still quite new. So at the start of April, we went through a hackathon. I think. Another one of those global hackathon of COVID-19, and then we won small grant, and we've been continuing this work for about a month, and looking forward, this is probably going to be a long-term project of mine, along with a lot of volunteers to help us. So we're called AIforGood Simulator. We're trying to model the spread of COVID-19 refugee camps, and this is our story. This is the first time we actually present to anyone else outside the team, so bear with me. The slides are a bit of low quality. I didn't like slap together any in this theme because we don't have a logo yet. That'll probably happen soon. So a little bit about me. So I did my master's in information and computer engineering at Cambridge. I graduated last year, and since then I've been working as a data scientist. So when I was in university, I got really interested in AI and machine learning very broadly. If you look at other sort of information engineering, it's actually quite new. You're looking at papers from 50, 60 years back, Shannon's theorem, that kind of thing. But AI and machine learning is such a new field. You see the breakthrough in computer vision in 2012 and all that. You're just like, this is so exciting. And I got drawn to that and took modules in probability, machine learning, deep learning, computational neuroscience, robotics, so a quite wide range of stuff. And afterwards, I want to focus on data science, and then specifically, I want to I landed sort of in this sort of AI for social good area that I'm really passionate about, because I had a passion for sustainable development goals, SDGs. When I was at university, I was organizing events around it. I founded a society called Engineering for Social Good. And after moving to London, I joined a company called AIforGood UK, and we do the kind of work we do is building AI empowered products for NGOs and different organizations around the world. So we have 2 chatbots. we still have two chatbots. One is live in South Africa, raising awareness about domestic violence, and the other one is in India, raising awareness on sexual reproductive health for teenage girls. So I was working on the NLP side of things, so super familiar to see all the Word2Vec, all the transformer stuff I was working on before. Really cool. And I as part of that, a co-founder community called AIforGood London, which is quite similar to the company, but it's actually just a community of people. Because we see in the field of AI or data science, you always like you guys probably have read a lot of news and heard a lot of discussion about AI ethics and all that stuff. And a part of that, people always say you have to start with a diverse team, and that's not the case in a lot of the big companies that you see. You have a diverse team, and then you start building a product. So we believe we need a diverse group of people who not necessarily do data science to come together really to build AI for social good purposes. So we have people from, obviously you have folks like data scientists, software engineers. We also have people from the public sector, the charity sector. Even we had a filmmaker in a lot of meetups. And then we used to host meetup every Tuesday in London in our office. That has been going on since last September. So if you guys anytime soon you're in London, hopefully the lockdown's over, feel free to check it out. We're on Meetup. If you just type in AIforGood London or AIforGood UK, you'll probably find us with this middle orange logo. So feel free to come down. And then since we moved to virtual, COVID-19 sort of happened, we moved to virtual, and we were thinking about what kind of project we can really do to COVID-19, thinking about the AI for social good our purposes as a community. What do you feel like there are a lot of people, this virus is not equal, and it reflects a lot of inequalities existing in society. There are a lot of vulnerable groups where it didn't really take care of. So we start mapping which vulnerable groups we could potentially help with. Of course, there's old people who stay at home who don't have the power to shop, and then you see a lot of innovations springing up over the world. In the UK, there's loads of mutual aid groups, and then spring up to help old people shop and all that stuff. And then you think about it, you have homeless people who are on the street, potentially quite exposed to the virus. And then another thing we looked at is the refugee population. As you know, like the situation is not very good in a lot of the camps, and the camps in general lack a sort of strategy to really combat COVID-19. If you look at the figure, number of forcibly displaced people worldwide, the camp environment they're working in, they're overcrowded, they have poor sanitation, a lot of malnutrition happen in a lot of camps, and then the medical condition is not great. Like for one of the camps we're looking at, Moria camp in the Greek island called Lesbos, there are only 6 ICU beds on the whole island, and that includes a lot of the residents who are actually on the island. So the camp is not the whole island. There are also residents. So this situation is quite bad. And my colleague and friend, Alice, who used to work for Refugees, maybe some of you have heard of the organization before, she had some contact on the ground. So she started having conversation with the people to really ask about the situation. And it seems like the camps, the authority, like this is kind of a political issue in the terms like in forms like the Greece, the Greek refugee camps. The Greek authorities are not really doing much before the outbreak, so they're not actively preparing it. It seems like the only thing that can happen and prompt them into action is for it to actually happen. But with that high population density, for this camp, we're looking at this Moria camp. You have 20,000 people in less than 1 kilometer square. The high population density means once you identify symptomatic cases, everything is probably too late already. The virus is probably going to sweep through the whole camp. So with this project, our aim is really to help the humanitarian NGOs working on the ground to validate the intervention strategies to contain the coronavirus and save lives. And how do we do that? We provide epidemiology modeling help to these NGOs. And epidemiology modeling is kind of like scarce resource at the moment because it's happening, coronavirus spreading everywhere, and then major universities like Johns Hopkins to the London tropical disease and I can't fully remember the name, but LSHTM, they are working on this issue, but they are focused on a national level. So like folks in Johns Hopkins will focus more in the US context, and the folks at LSHTM will more focused on the UK context. So they don't have the capacity spare to help these organizations to actually do the modeling. And we see a need, and we want to address this need. We have what we're doing right now. So we have 3 teams of volunteers split among 3 groups of people roughly. So we have modeling and engineering, and that group is in charge of building models and potentially building a platform later where we can really scale a help and scale a solution. And there's NGO outreach, and this group is tasked with reaching out to all the NGOs that are working other camps to find if there is a commonality that we can really scale our solutions in the future. And the last bit, the humanitarian research, we're engaging with humanitarian actors on the ground to observe what's currently happening in the camp and what kind of interventions are doable, and conducting some of the cost-benefit analysis of different interventions. For example, you see in the context of more developed countries, once you have a lockdown, economy suffers a lot, and then you have to account for that when you're planning the interventions. And as part of that, we're also engaging with a lot of humanitarian the research community, because in these low resource settings, you can't really do a lot of the interventions that we do here in Western Europe, for example. And you have to really sometimes think out of the box in terms of how to design the interventions and how to communicate to communities, and then trust the power of the community, because they can really come up with an innovative approach. And one story I heard about that is in the West Africa Ebola outbreak, when CDC, the agency in the States, predicted there's to be 1 million deaths in West Africa, but it actually didn't happen. And the NGOs, believing CDC, start building field hospitals that were never used, because communities there realize this is a very deadly disease, and they start social distancing among themselves. So they don't have the necessary PPEs, but they will let the sick people stay in the house, and they will deliver food to them in a way where they will have a tree branch, and then they hand the food with the branch rather than getting in contact with them. So community have a lot of power in terms of innovating some of these approaches, and that has to be taken into account as data, as a data source that can be fed back to the whole mechanism. And then now, in this talk, I'll focus on a lot of modeling stuff. So a disclaimer at the start: I'm not an epidemiologist. I had no epidemiology modeling expertise or any knowledge prior to this month, really. And in the past month, I've been reading up a lot of papers and collaborating with epidemiology modeling folks and some other software engineers to really understand this problem and really build out models. So the disclaimer there, so if there's anything too technical about the model that I can't respond, bear with me. So I'm going to walk you through the sort of what is an epidemiology model and how it's being set up. This is a slide I took from a PhD student that is currently working with us. So it actually resembles quite a bit with the sort of in data science, like machine learning, you have a black box model, and that essentially is the epidemiology model. So with the input parameters, you have COVID-19 specific parameters that coming out of research everywhere. There's also on this particular parameter issue, there's actually a research issue here where a lot of research we are seeing are coming from Europe and Asia, like China, South Korea. These data might not translate well to these contexts. For example, the incubation days, the number of infectious days, day to recover, the mortality rate. These might not be true in these settings. We have to make some assumption to start with. And the second one is really the camp parameters. And in this case, we're looking at the Moria camp. So parameters about population, age, gender, and all the other information we can get from the camp. And the third one is control strategies, which intervention strategies are possible and available in this camp, and then we need to factor these into the model. And you crunch these numbers through the model, and what a model produces is kind of a series of projections of different numbers. You can get like daily hospitalization, total hospitalization over the whole period of the epidemic if it's kicking. And you have number of critical cases out of those people who needs hospitalization, and the number of deaths is something we see from all the report we've been seeing from the government. So let's unpick this model a little bit more. So in the basic form of epidemiology model, you can model split into two states for each person. Um, this is disease status. So you have people who are susceptible, also like in terms of COVID, everyone who hasn't really contracted COVID yet, and you have infected people. And infected people will interact with the susceptible people and then infecting them more, and then therefore you have more people moving from S to I. And then if you added another status will be recovered. So once you susceptible people go through infected, and with some probability down the road, you will get covered. Like average number of days to recover, I think it's around 20 days from some of the studies. And you can add one more compartment, which constitutes the basic model that we're using in our in our the modeling approach, which is SEIR. You probably see a lot of articles now. The basic form is SEIR, and SEIR is the clever addition of that, because with COVID-19, you can see a lot of people might get exposed. This is according to current study. A lot of people are exposed, but they're not yet showing any symptoms, but they already can be infectious. So it's pre-symptomatic, and then infected is asymptomatic. Another fact you probably have seen the news is a lot of people are asymptomatic, and these people are actually spreading virus. For example, the test in Iceland suggests a lot of people are actually asymptomatic and moving around and spreading this disease. So you can add that as a status. And to further add it to this recovery case, or in some cases in literature you call it removed, because they also include people who are dead. But here we split up into sort of two strands. So you have people who are infected, and then they will move on to being hospitalized, and then some of the needing hospitalized, because in this case we don't have enough hospital capacity. And then you have a portion of people who are moving to critical, and then a portion of people moving from critical to death. I think once you're moving to critical state, your death is really, really high. So about like 50%, I think, or 20%. I can't remember. I can't remember the case. But yeah, those are the sort of setup of what's underlying the disease through the transmission dynamics. And with the models, epidemic models, this is a style I borrow from a really good talk from this guy from Emory, from Oxford College at Emory University. There's a three sort of broad categories of epidemic models. First one is the compartment model. This is probably the most prevalent model you have seen. I don't know if you have browsed some GitHub repo in terms of other people writing code. This is probably the easiest one to write, which I will show you in a bit. This is basically you divide population into groups, but still you treat them as a homogeneous group that will uniformly mix in this setting environment. You don't actually explicitly encode any spatial information in that. And then the speed of transition across disease states are solved with differential equations, and these equations are tested in all the influenza outbreak, Ebola outbreak, all the past knowledge of epidemiology sort of condensed into these equations. And then people have shown once you use this equation to fit the actual data, it actually fits really, really well. This is analytically tractable, but it's very limited for representing transmission processes, because you will just be monitoring people. The differential equation essentially tell you at each time step how many people move from E to exposed to infectious, from S to susceptible to exposed. It actually doesn't assume any sort of underlying mechanics. You just assume that somehow, these people get in touch, and then you have this number of people going into it. So you're looking at the system at a very high level. This is what compartmental do. But also it allows you, there's a flexibility to add on to this sort of compartment model, where you can add different age groups, because we know different age have different mortality rate facing coronavirus, different severity rate, and then perhaps different gender can have different mortality rate as well. So there are things you can add on. Then you can add on this thing called contact matrix, which some of you might have seen in the research, basically mapping out which age of people is interacting with which other age of people. So you will see parents interacting a lot with children, children interacting with parents. So you see this pattern you can encode. This is usually collected through survey. There are data available in the States and for population in the UK as well. You can see that. You can add that to this model. One thing about this model is once you start adding these features, you actually have to duplicate different models. For example, in our modeling, we model 6 or 7 different age groups, but to run that, you basically have to create a sub-model each and aggregate their results. So adding more features become exponentially hard as you go down the road. So this is not super scalable, but you can make everything work. If you check everything is, assumptions and everything is in line, your code doesn't make any mistake, you will get an accurate model out of it. Another thing to complement, another different strand of thinking is in this agent-based model where individuals within the population are representatives. So you have a heterogeneous population, and they can have different roles, different age, different sex. So you explicitly model each person as an individual, and then you can put them in some space structure. So you can put some people, you can say their home is here, and some people will go to work here, some people visit hospital here, some people use the toilet here, some people use whatever. So you can encode these activities in there. And then how do you decide who to infect? Basically, you have someone, one of the disease transmission mechanism, you can say, okay, when 2 agents come within 6 or 8 meters within each other, they have a probability of infecting each other according to this time equation, because the longer you spend time together, the more likely you will get affected. So you will be less likely if 2 agents are walking down the street and walk past each other, the probability of getting infected is very, very low. But if you have someone living in the same household, essentially the probability of getting infected will be really, really, really high. So you have this stochastic algorithm as well for transition across the states, because here in this compartment model with the differential equation, everything is deterministic. People will get infected, and everyone, if in a closed population without interventions, if the R naught, the reproduction number is higher than 1, everyone will be affected. But this stochasticity doesn't really guarantee the epidemic will actually happen, because every time you get in contact, you only have 0.1 or 0.05 or 0.01 of probability infecting each other, and everyone have those incubation days. So like the number of days taken you from exposed to infected will be drawn from a Poisson distribution, rather than say after 10 days you will definitely move from E to I. Here you can make them be like drawing from Poisson distribution. Someone would take 1 day, someone would take 20 days. That all have probability happening. So this agent-based view give you more flexibility in representing the individual heterogeneity, but one of the challenges is to simulate realistic contact processes. Are you including all the contact processes, or are you estimating those parameters right? Because currently there haven't been any, let's say, legit medical studies that shows what's actually the probability of you spending X amount of time with some people. This is still a sort of a guesswork that needs to be validated with research in the future. And the last bit is the sort of most, I guess, the more complex model than the 2 on the left. You have a network model. So what this model does, you simulate a social network or a network structure that represents the interaction between population first. Once you simulate this network, you run the COVID-19 infectious dynamics on top of this network. So with each edge connecting with 2 people, every time step you would say you have a probability of infecting each other with this number. And the network structure can change temporally, as like some people will go home at the end of the day. So you probably have a very fixed edge with everyone live in the same household, but you might have a few edges that dissolve in random time step. They might be friends of you from the other side of the camp, or they might be your neighbors you bump into in the toilet. That's the network structure will change. Therefore, your epidemiology dynamics building on top of that will change as well as the 2 evolve at the same time. This is a very rigorous model for contact processes, but you need a lot of data. So which is the next stage of the project. We really need to have data from the ground, and we are aiming to do that soon. This will give you like very, very big flexibility compared to all the other 2 models on the left. So now I'm going to go through each different model. So we are building the 3 models at once, and the idea behind it is every model is kind of limited, and some are more useful than others. Each model sort of tell you a different narrative of what's happening on the ground, and we would like to at least have 2 models where we can validate different assumptions against each other, because at this time, as I pointed out, there has been study coming out from these settings, and we don't really know the infection dynamics in these settings as well. So there's a lot of assumptions, and we have to have a couple models that do this thing. Any questions so far?
So I'm curious to see the results. Like, so no questions so far.
Yeah. So I think actually, what like with the results side of thing, this is still work in progress. I will show you how to set up these models, but we haven't actually finished the experiments. So maybe that's something you can check on our website later once we have all the intervention. When we run all the intervention, run the reduction. I think those things will be ready by the end of this week. That's our aim. Because we have different volunteers working on this project, they all have their full-time engagement. The progress is not as far as we hope, but that gives us further time to understand the problem, talk to different NGOs, really validate assumptions first before we endeavor to build anything. And then I think the fail fast and learn things approach is not okay into this humanitarian context, because you really have to deliberate with your approach so you don't cause actual harm in this context. So anyways, I will go through these models with everyone. So in the compartment model, how do you actually set it up? So assuming I'm modeling 4 different states of disease, and then the way to set it up, the big N is the total number of population you want to model, and you basically set it up to have n-1 in the susceptible stage to start with, and then you have a seeding of 1 exposed population and see how that pan out. And also you can start it with like 3 or 5, and that doesn't really matter. And here on the right is the set of differential equations that govern the transmission process in this deterministic compartment model. So you can see some beta, this parameter is related to the reproduction number that we have seen, the R naught. This is, I think, beta is R naught divided by number of days someone stays infected. So beta is directly related to R naught. You have these people like moving from E to I, so you lose them. So this is kind of like a different equation in terms of like a different, and then you sort of transform that into differential equation. But a fairly intuitive process, and you just basically need to follow these equations to set them up, and then use the ODE solver. And then SciPy already has that function, so you use the ODE solver, and then you can nicely get all the setup. So now I'm gonna show you how to do that in the code. I have a few notebooks set up because we still on the process of aggregating all the repos together. So I have a few different repos, but in the future they will be under our organization GitHub, hopefully. So here is what I was talking about. You first set up the ODE system that, the DY/DT. So number of people changes. So here you have DSDT, DEDT, DIDT, DR. And then this model has the 3 extensions I mentioned. You have like H, C, and D. And then this is basically a bookwork of copying those parameters from the equation I just showed you into the model. So this can be copy and pasted from a mathematical modeling, epidemiology modeling book, and you can set that up. And then here is what I mentioned when you have different age groups, how you set it up. So with different age groups, you basically set up a submodel for each age, and then track their progress over time. And here, when you run the model, once you have the ODE, you basically set up this receiving data frame or NumPy array that you call, and then you set it up. After set up, you basically call this ODE solver, which is imported from SciPy integrate. So quite handy there. So once you run the ODE,
presenter live. Another thing is being an inspiring presenter behind a video camera. So if you guys know anybody, let us know. We're always looking for active speakers to tell their awesome stories.
And thanks for attending, Bart. Quickly switching
There we
over.
go, Ruben. There you go. Thank you, Ruben. Ruben exists. He's not a bot. For those of you who don't know him, very good. All right. So if no one has any new ideas, cool suggestions, I'd like to maybe call it a night. Thank you very much, Ruben, team, everybody. Looking forward to seeing you again sometime in the near future. Very much appreciate it. Take care and stay safe, everyone.
Hey guys.